Hi students, welcome to physics class. Today we are going to discuss about some important definitions, that is triangle. Triangle law. Triangle law of vector. Triangle law of vectors. Now go for the discussion. Today our concept is triangle law of vector. Now take here, it is a vector A. The vector A name is considered as OP. Therefore, OP vector is equal to nothing but vector A. Now, I would like to take another vector from P to Q. The P to Q we called a vector B. That means here PQ vector is equal to a vector B. Now where is the resultant? The resultant is from O to Q. The resultant is from O to Q in this direction. This is called vector R1. Okay. Now what we understood? We understood that OQ vector is equal to resultant vector R1 or vector R1. Okay. Therefore, the vector R1 is equal to the A vector plus B vector. A vector plus B vector. This is we can call as triangle law of vector. That means OP is a vector. Its name is consider vector A. The head is at P. Now we draw another vector, that is PQ. The head is at Q. Now the resultant is from O to Q. Here the head is at Q. The tail is at O. Therefore the resultant vector R1 is equal to A plus B. Now go for discussion. Explanation. It states that if two vectors acting on a particle at the same time are represented in magnitude and direction. In magnitude and direction by the two sides of a triangle. Two sides of a triangle taken in one order, comma, their resultant their resultant vector is represented in magnitude and direction. In magnitude and direction by the third side of the triangle taken in opposite order. Once again, I am repeating triangle of vector. We already saw the diagram. It states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two sides of a triangle taken in one order, their resultant vector is represented in magnitude and direction by the third side of the triangle taken in opposite order. This is about triangle of vector. Now we are going to discuss about parallelogram law of vector. Parallelogram law of vector. Parallelogram law of vector. Now we are going to discuss about parallelogram law of vectors. Now take a vector that is OP. That OP is a vector A. Now take from its head to another vector that is Q. Here PQ is equal to vector B. Now this is the resultant. The resultant is from O to Q. That is we called as a vector R. Now I took a parallel. Consider this is S. Now I draw another parallel to A, that is SQ. Consider it is A. Consider it is B. Okay. Now this is a parallelogram. Remember, this is a parallelogram. Here, according to parallelogram law of vectors, it states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two Once again, it states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, their resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point is called parallelogram law of vector. However, I would like to explain once again by point. First, draw this diagram. It states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point the resultant vector is represented in magnitude and direction by the diagonal of the parallelogram. Drawn from the same point is called parallelogram law of vector. Once again, I am repeating the point. It states that if two vectors acting on a particle at the same time are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, their resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point is called parallelogram law of vector. Now note, consider x-axis, y-axis, z-axis. This is origin O. Along x-axis, the unit vector is I. Along the y-axis, the unit vector is J, fix. Along the z-axis, the unit vector is K or K cap. Along x-axis, I cap. Along y-axis, J cap. Along z-axis, K cap. Similarly, take x dash and y dash and z dash. Along, this is origin O. Along x-axis, the unit vector I. Along y-axis, the unit vector is j cap. Along z-axis, the unit vector is k cap. Consider I dot I is equal to 1. J dot J is equal to 1. K dot K is equal to 1. That means I dot I 1, J dot J 1, K dot K 1. At the same time, I dot J is equal to 0. J dot K is equal to 0. K dot I is equal to 0. That means I dot J 0. J dot K 0. K unit vector dot I unit vector is equal to 0. I dot I unit vector dot J unit vector 0. J unit vector dot K unit vector 0. K unit vector dot I unit vector 0. These are very very important points. And also I cross I is equal to 0. J cross J is equal to 0. K cross K is equal to 0. And I cross J is equal to K. J cross K is equal to I. K cross I is equal to J. Similarly, now reverse. K J cross I is equal to minus K. K cross J is equal to minus I. I cross K is equal to minus J. This is the very important points. Please remember. And also I dot I is equal to mod I cos theta. Similarly, A dot B is equal to mod A mod B cos theta. And also A cross. Now come to here. If we are discussing here dot point or cross product, now we are going to discuss about cross. I cross J is equal to mod I mod J sin theta into unity vector. Similarly, A, it is a vector, it is unity vector. Similarly, A vector cross B vector is equal to mod A mod B sin theta into unity vector. Now take positive x-axis, positive y-axis, positive z-axis. Consider it is a vector A. It is a vector A. Here is I vector, along is J vector, along is K vector, K unit vector. Now we have to remember that this is considered as AX. This is considered as AY. This is considered as AZ vector. That means A vector divided into three parts. AX vector, along Y direction AY vector, along Z direction AZ vector. That means along AX direction, along X direction, AX vector is equal to unity vector into AX. Along Y direction, AY vector, this is also, we can also write as like this: AX vector, AY vector, AZ vector. AY vector is equal to J unity vector into AY. J unity vector into magnitude of AY. Along Z direction, A Z vector is equal to K A Z vector is equal to K unity vector into AZ. These are the important formulas we have to remember. From this one, what we understood? I vector is equal to AX vector by, we remember that I unity vector is equal to AX vector by AX or AX vector by mod AX magnitude. Similarly, J unity vector is equal to AY vector to the AY or AY vector to the magnitude of AY. Okay, magnitude of AY. Now similarly, K unit vector is equal A Z vector to the magnitude of AZ. How we can as magnitude? This is called magnitude, that is AZ by it is a vector AZ vector. So unit vector K is equal AZ vector by magnitude of AZ. Similarly, AZ vector to the magnitude of AZ. These are the formulas we have to remember. These are very important. Next video we can discuss about polygon law of vectors. However, thank you very much for watching this video.